All right, grade 12s, we're going to be looking at exponential functions and their graphs today. I won't be long, there's the good news. First of all, recall on what a function is. A function has one y value for every x value. Another way to say that is that every element in the domain is mapped to exactly one element in the range. Okay, so one y value for every x value works well for a table of values. If we have a graph, one way of deciding whether it's a function or not is to look at the vertical line test. If a vertical line passes through a graph only once in any place, you have a function. So let's look at 2 just briefly as a recall. If we have y equals x squared, which is old and familiar, I'm just going to write a table of values. I am squaring each x value. I will have positive 1, 0, 1, 4, and 9. If I look at my x values, there is one y value for every x value. And if I were to graph it, I have the point 0, 0, minus 1, 1, and 1, 1, 2, 4. Everything is identical on the left side as well. 3, 9. I have a parabola, a crooked parabola apparently. And if you were to put a vertical line anywhere in that graph, besides the terrible drawing, it would indicate that it is a function. Let's do a table of values for y equals 2 to the x. So this is where our rules of powers come in. So I am going to have, sorry, didn't mark that on the other grid. Let's do the same, minus 1, 0, 1, 2, and 3. 2 to the negative 1 from our rules of powers is a flip, so it would be 1 over 2. Anything to the power of 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. So our table of values will, I always do my x is 0 first. 1, 2, 2, 4, 3, 8. Wow, that's growing rapidly. A half, that's hard to get on a smartboard, and a quarter, and so on. We have our graph. There we are. It is a function because any vertical line test would only hit that graph in one place. So it is a function. Some other things we know to talk about with a quadratic would be the domain, the range, and the intercepts. Now I've erased the graph, but the domain for a parabola would be x can be any real number. The range for a quadratic has a limit. For the particular parent function that I've drawn right now, y has to be greater than or equal to 0 and is a real number. Let's look at our green function, y equals 2 to the x. The domain would also be x can be any real number. That function will go to the left and the right forever, unless it's a real life problem, and that's a different issue. The range also appears that it is above the x-axis. It also doesn't touch the x-axis, so it would be y greater than 0. Y is a real number. This line, which the function is approaching but never touches, is called an asymptote. Be careful. There we are. X-intercepts. You know a parabola could have 0, 1, or 2 x-intercepts. For this particular parabola, there is one. It is at 0, 0. Y-intercept, there is always one y-intercept. For this particular parabola, it is also 0, 0. The y-intercept is where it meets the y-axis. X-intercepts, of course, are where it meets the x-axis. Let's look at our new function. There are no x-intercepts. It does not meet the asymptote. There is a y-intercept. Of 1. And as a recall, I would like to just remind you of the rules of powers, because you're going to be doing an investigation with powers. If you have a multiplication and have the same base, the rule would be add the exponents. If you have a division with the same base only, our rule would be keep the base, subtract the exponents. The power of a power is when you have a power raised to another exponent, and we would keep the base, multiply the exponents. If you have a negative exponent, it would be, well, it's not very mathy, but a flip. If you have a 0 exponent, your answer is 1. Our rational exponents don't come into play for the graph today, so I'm going to ask you to do the investigation 1.1.1, 1.1.2, and 1.1.3, and I think you will have a grasp of these graphs better than if I just do it for you.